All right, so what we are going to do today is a continuation of our unit on KMT and gas laws. The first gas law that we're going to look at is Boyle's law. And then next week, next Tuesday and Friday, we will cover Charles' law and Gay-Lussac's law. Now, in order for these gas laws to make sense, you have to have a good understanding and background knowledge on kinetic molecular theory because we're going to continue looking at our three variables that we talked about with kinetic molecular theory: volume, pressure, number of particles, and temperature. Now, for each one of our laws, gas laws that we're going to look at, starting with Boyle's law, we're going to look at the relationship between two of those variables, and then we're going to take a third variable and keep it the same. So our first one is going to be Boyle's law, in which we're going to keep the temperature constant, and we're just going to look at the relationship between volume and pressure. So, and we're going to see that this is a inverse relationship. Okay, so as the volume decreases, the pressure increases. And if the volume increases, then the pressure will decrease. So we can use that relationship between pressure and volume to help you understand how your lungs work. This is how you can breathe and constantly take in air and breathe out carbon dioxide without ever having to consciously think about it, all because of Boyle's law. So when you breathe in, when we look at this picture here on the left, when you breathe in, the volume of your lungs increases. As the volume increases, the pressure decreases. This decreased pressure in the lungs, in other words, the pressure in the lungs is less than the external pressure, the pressure outside of the lungs. So therefore, air rushes in through your nose, through your trachea, into your lungs. When you go to breathe out, your diaphragm relaxes, the volume of your lungs gets much smaller. A decrease in volume means an increase in pressure. So now that carbon dioxide rushes out of our nose, out of our mouths, into the atmosphere around us, into the external atmosphere. So that's one application of Boyle's law in your everyday life. Let's look at what Boyle's law looks like when it is graphed. So pressure is your independent variable, and if you remember, your independent variable is going to be on the x-axis, and then volume is your dependent variable, which will be graphed on the y-axis, and the temperature has to remain constant. Now notice, remember, we have an inverse relationship between volume and pressure. And whenever we have an inverse relationship, that's when we get these curves to the graphed data. Now, in a direct relationship, which we are going to see next week for Charles and Gay-Lussac, we're going to see that we get that diagonal straight line. Okay, so this is once again some of the things that makes Boyle's law different from our other gas laws. We see an inverse relationship, and we see a graph that looks differently because of when the data is plotted, the graph looks different because of that inverse relationship. We get that curved line. Don't forget that pressure has a lot of different units, okay? We have atmospheres, kilopascals, millimeters of mercury that you're responsible for. Volume. Volume can be in milliliters or liters. Now, our formula for Boyle's law is pressure 1 times volume 1 equals pressure 2 times volume 2. Um, this means that the initial pressure times the initial volume will equal the change in pressure times the change in volume. Now, as long as you have 3 out of these 4, you can solve for the fourth just by manipulating the equation and doing a little bit of algebra. I'm going to solve a Boyle's Law problem for you in just a bit to show you how this formula can be used. But first, before we do that, I have some links here to a couple of different websites. The first one is for a website called ChemTeam. It's a great website. Now, it is an older website, so it doesn't have all kinds of great graphics or neat color backgrounds, any flashy GIFs or anything like that going on. But despite the fact that it is very boring looking, it has fantastic explanations of Boyle's Law and how the Boyle's Law relates to kinetic molecular theory. ChemTeam also gives lots of example problems. They work them out. They have the answers right there so that you can work them out and look and check your work along with them. And also the other thing that I really love about ChemTeam is that it really does try to help students understand how a teacher may try to take Boyle's Law and just make it maybe a little bit more tricky. So I highly recommend that you just take 20 minutes and click on the website and check it out. Read it. Work out some of those example problems. Pay attention to some of the things they say that a teacher can do to try to make Boyle's Law problems look more difficult than they actually are. The other thing that I have here is for a YouTube video from Flynn Scientific, and it shows you how to make a straw popper or how to make a water bottle popper. And it's a pretty neat, fun application of Boyle's Law that you can try at home. Now, if you choose to try these at home, make sure you're doing it outside, you're doing it away from people, animals, and windows, and don't aim it towards your face. As the famous Christmas movie says, you'll shoot your eye out, kid. So, if you do try to do any of these, go outside and make sure there's nobody around. All right, so with that in mind, let's go ahead and try to work this example problem that I have here on Boyle's Law. And as always, let's start off by making sure we're using good, proper problem-solving technique. So if I initially have a gas at a pressure of 12 atmospheres, a volume of 23 liters, and then I raise the pressure to 14 atmospheres, what is the new volume of the gas? All right, so our pressure 1 equals 12 atmospheres. Volume 1 equals 23 liters. And then they raise the pressure. Okay, so that change in pressure, that's our pressure 2, 14 atmospheres. And what you're trying to solve for, our unknown variable, is the change in volume. All right, so let's take that information and let's go ahead and write our equation for Boyle's Law. And let's go ahead and manipulate that equation so that we have the V2 by itself. So that's going to look like this. Now that we have the equation manipulated, let's go ahead and put all of our numbers in there and their units. So if we have 12 atmospheres times 23 liters, and we're going to put that over 14 atmospheres, and that's going to equal our change in volume. As always, let's check and make sure the proper things cancel out. Atmospheres at the top will cancel out atmospheres in the bottom, leaving us with just liters, which is fantastic because we are solving for a volume. So far it looks like we are on the right path. So now let's take this information and let's put it into the calculator. So you're going to end up putting 12 times 23 into the calculator, hit enter, then take that answer and divide it by 14. And when you do that, you are going to come up with 19.7 and lots of other numbers after that. Now, let's look at our measurements here. Let's see how many significant figures we have. So we have 2 sig figs here, 2 here, 2 here. So it looks like our final answer should also have 2 sig figs. So if we underline, look behind, we will see that the 7 is going to raise the value of that 9, so that we're going to come up with 20. Now, when we're looking at 20, does that show 2 significant figures? No, it does not. So we've got to find a way to take this number so that it is showing 2 significant figures. Remember, that can be done one of 2 ways. You can either put a decimal there and then put your units, or we can take that number and change it into scientific notation. So we can say 2.0 times 10 to the first liters. Okay, either one of those answers would be the correct way to write our change in volume. Now, the other thing I would like you to do to help ensure that you're on the right path is ask yourself this question: does your answer make sense? Okay, so remember, we said we have an inverse relationship between pressure and volume. And what we see here is that the pressure, what was the change in pressure? Did it increase or decrease? Okay, we went from 12 to 14. So we see that the pressure increased. If the pressure increased, that must mean that our volume then, because it's an inverse relationship, decreases. So now let's go back and check our number, our answer. Is 20 a decrease from the initial volume? Yes, absolutely. So this should give you some sense that your answer is more than likely correct. Okay, this is a great way to check. And you understanding the relationship between your variables in your equation. Is it an inverse relationship? Is it a direct relationship? Is so super important in order for you to check that your answer makes sense. All right, so let's do a quick little review of what's important from Boyle's law. All right, so you want to make sure that you understand that Boyle's law shows an inverse relationship between volume and pressure. Okay, we see that inverse relationship. And you also want to make sure that you understand which variable is graphed is on the x-axis, which one is graphed on the y-axis. You understand what the general shape of Boyle's law graphed would look like. Remember, we said because it is an inverse relationship, we're going to see that curved line. Make sure you know your formula for Boyle's law. Notice here I have P1 times V1. Every now and again, if you go to a YouTube video or on different websites, you may see that written as P sub I, pressure, so initial pressure, initial volume. Okay, just in case you might see it written a little differently on a website or a YouTube video. You need to make sure that if you are given 3 of these factors that you can solve for the 4th one. And you have some great resources here from the internet. They may help you better understand and give you even more practice on Boyle's Law problems, the relationship between Boyle's Law and kinetic molecular theory. And of course, you need to be able to solve problems using Boyle's Law. All right, so that's all for today. Don't forget, you have a Flipgrid video due by 10:25 today. And then the Boyle's Law worksheet will be due on Tuesday by 8:30 a.m. Y'all have a great day.